We are ready to start section 5 of chapter 4, simplifying square roots. You were practicing finding square roots and even approximating them. Now we get to real algebra with square roots, so we will see more complex expressions inside the radical. So product property of square roots. The product property of square roots. Product means what operation? Multiplication. We're multiplying square roots together today. And we are going to find out how we need to write the answer. We need to write our answers in math, usually in simplified form. So we're going to be using that today. So if we have square root of 36, that's already just a little value given, right? 36. We already know what the square root of 36 is. So that's why I like using this example, because you already know the answer should be 6, because it is a perfect square already. But we could take the square root of 36 and write it differently. Can you think of two factors that are perfect square factors that multiply them together, you get 36? They have to be perfect square factors.
6.
6 is not a perfect square factor. Square root of 6 is not, see, it's not perfect, right? So we need perfect square factors.
9 and 4.
Very good, Gavin got 9 and 4. So we could write square root of 36 like this. Square root of 9 times 4. And the square root of 9 could be actually separated from the square root of 4. Do you see that? We all know what the answer is ultimately going to be, but I want you to see that we can take a little product, 36, and we can start factoring it. If we see these perfect square factors, we can literally pull them apart, and square root of 36 equals the square root of 9 times the square root of 4. Because what is the square root of 9?
3.
And what is the square root of 4? And 3 times 2 is, which is what we knew the square root of 36 was. So make sure you have this series down, okay? Because we are going to use this same property with variable expressions, okay? So make sure you have it down. Here it is as a rule, again. Remember to raise your hand if you have a question or a comment. When we create math rules, we use variables that could represent any number that you would want to put in, right? So the square root of AB could be written differently. How could you write it? Brian? Well, you could switch, he said you could switch the factors and say square root of B times A rather. You could. That's true. Colin?
Could we do A times B?
Or Kate? Well, you're giving new letters. How about, could we separate these two factors?
Yes.
It would be the square root of A times the square root of B. You could separate them into their unique little factors. And these expressions are still equal. They're equivalent. Okay? When we have variables in our rule, we have to make little notes that tell us what is may or may not be allowed. So A and B must both be greater than or equal to 0. If you are greater than or equal to 0, what can we call you? Give me another name for that. If you are greater than or equal to 0, you are positive, right? Is that what you said? Positive? Okay, so why can you not be negative? Why can I not be negative inside of a radical? Like this. Square root of, give me a perfect square number. 20, okay, square root of negative 25. I mean, we know the square root of 25 is,
5.
so what's the square root of negative 25?
Negative 5.
Is it negative 5? So if it was, then negative 5 times negative 5 equals negative 25?
No, positive.
Oh, positive 25. So what would the square root of negative 25 be?
5.
No. We know this. Let me bring it down to an easier number. How about negative 1? We know the square root of 1 is 1. So what's the square root of negative 1? 0? 0 times 0 is negative 1? 1 times 1 is negative 1? Negative 1 times negative 1, is that negative 1?
Negative 1 times 1. Negative 1 times positive 1.
Oh, but wait, if we take a square root, Jake, stop. If we take a square root, that root, when we square it, should become the perfect square that we started with, right? But whenever we square a number, we always get a positive. So can we find a square root of a negative? Can we really? No, not a real number. We can't find a real number that works for this. Negative 1 times negative 1 does not equal negative 1. 1 times 1 does not equal negative 1. There is no real number that is the square root of a negative. So when we make a rule involving radicals like this, notice that anything inside the radical must be positive, or it could be 0. The square root of 0 is 0. 0 times 0 is 0. It works. Okay? It is. That's true. Okay. Here are here's a little list that shows us what must be true if we have a radical in simplest form. So if your radical is in simplest form, there should be no perfect square factor in the radical other than 1. And there should be no fractions in the radical, because there should be no radical in the denominator. Sometimes these are listed as 3. This no radical in the denominator sometimes is listed separately, but if you have a fraction in the radical, then you do have a radical in the denominator. So to me, they're linked together, and there are 2 things that must be true for a radical expression to be in simplest form. Okay, so no perfect square factors in the radical and no fractions in the radical. So let's try that here. We're going to simplify these radical expressions. And we're going to use that product property that we were just trying. Okay? So 490. We want to find the square root of 490, but actually we don't want to find the actual square root. We want to just simplify the radical. So we want to take out any perfect square factors that are in that radical. And we can start by factoring it. Do you see a perfect square factor in here? What is it, Alex? Actually I'm thinking something a little bigger. Actually 4 might be in there. But what? 49. So we can say 49 times what would get us back to 490? 49 times 10. Okay, so we're just factoring. And as we learned already, we could separate these into square root of 49 times square root of 10, right? What is the square root of 49, everyone?
7.
So we can now write this as 7 times the square root of 10, right? Now, does the square root of 10 have any perfect square factors in it? Give me the factors of 10. Audrey?
5.
5 times what?
2.
So we could write, instead of 10, we could write 5 times 2. Are either of those perfect square factors, though? No. So we actually have simplest form if we just leave this as 7 times the square root of 10. And we can even write this more simply. We can say 7 square root of 10. That's a 7 right there. 7 square root of 10. When you see a number sitting next to the radical, the operation is multiplication. That's our invisible operation. Okay? Okay, how about 112? What factors are in 112? And if you don't know right away, there's an easy one. It's an even number, so we could say, Spencer? You think 12 can go into 112?
No.
12 times what is 112? Why don't you just start with 2? 2 times what goes into 112? 2 times 56. Now, are either of these perfect square numbers? No? So let's keep factoring. We have 2 times, instead of writing 56, what goes into 56?
8 and 7.
8, okay, we can write it as 8 times 7. Are either of those perfect square factors? 8 is? What's the square root of 8? No, but what's inside of 8? We have Well, there's a couple ways to look at this. Right now, we could factor 8, right? And 8 is what? 8 equals, what is it? 4 times 2. Now, do you see any perfect square factors now? What is the perfect square factor that you see? 4. And what's the square root of 4? So we could take this square root of 4 out. But when we take it out, the square root of 4 equals 2, right? So we take a 2 out. Now, do we have any other perfect square factors in the radical? Who sees it? We have 2 times 2 times 7. Do you see the perfect square factor? When you have the same factor happening twice, don't you have a perfect square there?
Yeah.
What is 2 times 2?
4.
So here we have another 4. Do you see that?
Yeah.
So for this pair of 2's, how many 2's may we take out? We may take out 1, because 2 times 2 is 4, right? The square root of 4 is 2. We were able to take 2 factors of 2 out of the radical. And all that's left inside is a 7. Now, is that a perfect square? So it stays in. It is not a perfect square. It stays in. But on the outside, could we simplify 2 times 2? And call it 4, right? Looking back up here, what is 2 times 8?
16.
And what's the square root of 16? And isn't that what we got out? See? So sometimes people are able to see the larger perfect square factors and take those square roots out earlier. But if you don't see them, you will end up getting to the same expression later if you've taken all perfect square factors out. Okay, so it can be done either way. Okay, let's try this. This is interesting. We have a variable expression, 245b. The square root of 245b. Okay, so we see that 5 can go into 245. 5 times what? What'd you get, Will? 49. Good. 5 times 49. And we still have the b, right? And so do we see a perfect square factor now? Do we see it? What is the square root of 49? 7. So we can take out the square root of 7. And we still have 5 and b in the radical. Are either of those perfect square factors? Not that we know. We don't know what b is, so we have to leave it in, right? So we say 7 times the square root of 5b. And we have simplified the radical. This is how you simplify a radical. We're not actually finding the square root, are we? We're just simplifying it by pulling out the perfect square factors. You might be told what the value of b is at some point. And so what would this expression equal to the nearest whole number when b equals 14? Go ahead, jot that down and let's try it. When you're given a value for a variable, what is the method we use? b equals 14. So what do you do with that? Say it, Teddy? Plug it in, plug it in. Substitution. You're substituting it, right? So we can take the original expression, 5, there's a b in there, right? 7 times the square root of 5b. And instead of writing it that way, we can plug in 14 for b. 5 times 14. Are there any perfect square factors in 14? Give me the factors of 14. 7 times 2. Are either of those perfect square? And the other factor we have in the radical is a 5. So let's go ahead and multiply. What is 5 times 14? 5 times 10. Plus 5 times 4, which is 20. Good. So 70. We have, I'm going to bring this up here. 7 times the square root of 70. So we're being asked to find this value to the nearest whole number. So square root of 70, what would your estimate be? What's the closest integer that the square root of 70 is near, Colin?
64 and 81.
64 and 81. Which one's it closer to?
64.
64. So what's the square root of 64?
9.
No?
Oh, 8.
8. So we're going to say that the square root of 70 is about 8. 7 times 8 is
56.
Why do I have the 7 here? 7, I said 7 times 8. Why did I say the 7 there? Do you know why? Do you all know why? Square root of this number here became 8, but we still had a 7 outside the radical, right? So we had to bring that down and multiply. So the closest whole number that this is to is 56. Okay, so we were able to expand little products before. Now we're going to take two factors that are in radicals and condense them down into one. Okay? So we have the square root of 18 times the square root of 27. We can actually take those two factors and put them all inside of one radical. But that's not a simplified answer yet. So before you start multiplying 18 times 27, rather than multiplying, what could we do? Right?
Simplify 18 and then simplify 27 and then
Right.
multiply.
I think what you mean is that you're factoring them, right? What do you see in 18? 18 is made of 2 times what? 2 times 9. And 27 is 9 times 3. So do you see, we now have some beautiful factors for each of these numbers. And do you see the perfect square? What is the big perfect square that's here? Spencer? Actually, it's 9 times 9, right? Which is what? 81. So we could write 9 times 9 is 81, or we could just circle these two factors, and how many would we bring out of the radical? We'd bring 1 out, right? We'd bring 1 9 out, because the square root of 81 is 9. Now, 2 and 3, are either of those perfect squares?
No.
So we can't take their square root out, but we could just multiply them together and simplify this, right? What is 2 times 3? So we have 9 times the square root of 6, and there is your simplified expression. Okay, so you may need to pause the video and see how these worked out. And we're going to try a little bit more. Okay, you might need to pause the video and take a look at this. There you go.